Okay, so just a quick little side trip here. When we talk about multiplying fractions, for example, 3/4 times, I don't know, 7/5. We're going to go straight across the top and then straight across the bottom. So we get 21 over 20. Okay? The same thing is true when we get more into rational expressions, meaning now we have polynomials in the numerator and denominator, and we're multiplying a few fractions together. Okay. So it says let A, B, C, and D be polynomials. So A over B times C over D. Again, we're going to go straight across the top. So we have A times C, straight across the bottom, B times D, where B does not equal 0 and D does not equal 0, because again, we cannot divide by 0. Okay. So let's start off a little basic. A monomial over a monomial times a monomial over a monomial. So going straight across the top, 3x squared times 6x squared. 18x to the 4th, good. Over 4x times 9x to the 3rd. 36x to the 4th. Okay, remember, when you multiply variables, you add your exponents. Okay? So let's talk about restrictions. X cannot equal what? Look at your bottom. X cannot equal 0. That's the first part of our answer. Second part now is to simplify. Is there anything that we can cancel out? X to the 4th we can cancel out. And then what about 18 and 36? Do they have a common factor? Nine is a common factor. 6 is a common factor. What is the greatest common factor? 18. Good. So if we simplify top and bottom by 18, what's left over on top? 1. And what's left over on the bottom? 2. I know it seems kind of silly that we have this x cannot equal 0 when our final answer does not have an x in it. It's going to come into play much later once we start solving equations, so we're just going to keep this in good practice. Just keep stating restrictions. Okay, example 2. 5x squared minus 5x over x squared minus 7x plus 10 times x squared minus 3x minus 10 over x squared plus 16x. Okay, so we have 4 parts here, right? We have this upper left, lower left, upper right, lower right. We're just going to factor each of those sections first. So let's take a look at the upper left section. 5x squared minus 5x. How can we factor that? Factor out of 5x. And what's left over? X minus 1. Over lower left, x squared minus 7x plus 10. How can we factor that? X minus 5, x minus 2. Okay. All right, we're multiplying. So what are we going to do with the values on top? They go straight across, right? So what we're going to do here is we're going to take our fraction bar and we're just going to extend it. And now we're going to factor x squared minus 3x minus 10. X minus 5 and x plus 2. What about 8x squared plus 16x? Common factor of 8x, leaving us with x plus 2. All right, how many pieces in the denominator contain an x? 4 of them, right? 1, 2, 3, 4. So let's list all of the restrictions. X minus 5 tells us that x cannot equal 5. X minus 2, x cannot equal 2. 8x, x cannot equal 0. Because remember, we would take 8x, set it equal to 0, divide by 8. That's just 0. X plus 2, negative 2. So those are the restrictions. Now, let's take a look at what's on top and take a look at what's on bottom and see if we have any common factors that we can cancel. X plus 2's we can cancel out. X minus 5's we can cancel out. Anything else? The x's. Good. So what's left over in the numerator? A 5 and an x minus 1. So 5 times x minus 1. And then on the bottom, yes, we have the x minus 2 and we have an 8. I'm the same way. I like to put my 8 out in front. And then the x minus 2. Okay, so do you see how it's just a little bit of an extension? Okay. No, so yeah, so right here, your first thought is like, oh my gosh, I have to FOIL all that. You don't. We're going to factor and simplify. Okay? So x squared minus 9. X plus 3, x minus 3. Over 5 times x plus 3. I'm multiplying, so I can go ahead and just extend that fraction bar. 4x plus 4. Factor out of 4, left with x plus 1. X squared minus 7x plus 12. Both negatives, yep. X minus 4, x minus 3. Again, if you want to say x minus 3 first and then your x minus 4, that's fine. Okay, how many factors in the denominator contain a variable? 3. So that means we have 3 restrictions. What are they? Okay, does 5 contain a variable? No, so we don't have to worry about that 5. So the x plus 3 tells us x cannot equal negative 3. Good. So negative 3, 4, and positive 3. Now let's cancel. What cancels? X minus 3's cancel. X plus 3's cancel. So what's left in the numerator? 4 times x plus 1. And in the denominator? 5 and x minus 4. Very good. Last one, then we're done. Okay, upper left, 2x. What do we do there? Don't do anything, it's just 2x. Lower left, x squared minus 6x plus 8. Negative 4, negative 2. So x minus 4, x minus 2. We're multiplying, so we can extend our fraction bar. Where is this x minus 4 going? Is that an upper right or a lower right? It's an upper right because what is it over? A 1. Good. So we have x minus 4 in the numerator. That 1 is just a placeholder. You don't have to rewrite that. Okay, what are the restrictions here? 4 and 2. Very good. What cancels? X minus 4's. And what remains in the numerator? 2x. And the denominator? X minus 2. Okay, can you simplify that? This is the most common mistake. You see that 2 right there, you're going to want to just cancel it with that 2. But we can't, because what's the operation between the 2 and the x here? Multiplication. What's the operation between the 2 and the x down here? Subtraction. So in the numerator, the 2x, those are factors because they're being multiplied. In the denominator, these are terms because they're being either added or subtracted. You can only cancel factors, okay, only when you see multiplication. So this is our final answer. We can't cancel anything else. Yeah. Okay. So your homework, 8-1. You're now going to do 7 through 14. Okay, 7 through 14. And then tomorrow we'll talk about the division. The division has like 1.5 extra steps, we'll say. It's really not that much different than multiplication. All right.